We're going to talk about multiplying whole numbers times fractions and fractions times fractions today. The first example I'm giving you is an example you would see when doing a recipe. Suppose I need half a cup of liquid for my recipe, and I need to have 3 recipes. I need to end up having 3 sets of a half a cup of liquid total for the recipes. So I'm going to show you what you have when you actually take the half cups and put them together. I have a half a cup of liquid in the measuring cup on the right. I'm going to empty it into the measuring cup on the left. That represents 1 half. Then I'm going to get another half cup of fluid, and I'm going to put that into the measuring cup on the left. You can see now I have a half a cup, plus a half a cup is a cup. Then I add 1 more half cup of liquid to the cup on the left, and I get a total of 1½ cups of liquid. So 3 sets of 1/2 gives me 1½, or 3 halves. I know that multiplication is a fast way to add. For instance, 3 times 4 is 12. Or I could say 3 sets of 4, which would be 4 plus 4 plus 4 is 12 also. I can apply that same idea with fractions. In this case, I needed 3 sets of 1/2. So I can say 1/2 plus 1/2 plus 1/2, which gives me 3 halves, or we know because we're able to change improper fractions to mixed numbers, I have 1½. Another way to represent this is to use a number line. Here I have a whole and then 2 wholes. If I take 1/2 plus 1/2 plus 1/2, I get 1½, which is the same as 3 sets of 1/2, or 3 times 1/2. Here's another problem. Cesar ran 3/4 of a mile in 6 minutes. After he finished, his coach told him that he only needed to run 2/3 of that distance in 6 minutes to qualify. How much of a mile did Cesar need to run in 6 minutes? Here's a picture to represent that problem. The whole rectangle from left to right represents a complete mile. It's divided into 4 sections so that we can show how much of that whole mile Cesar ran in 6 minutes. It's divided into 4 sections and 3 of them are shaded. That's 3/4 of a mile. However, Cesar's coach told him he only needed to run 2/3 of that distance in 6 minutes to qualify. That means that I could look at the shaded part as the whole amount. Cesar only needed to run 2/3 of that. Since the pink part is separated into 3 equal parts already, I just need 2 of those parts to represent 2/3. Each part is a fourth, so it's 1/4 plus 1/4, or 1/2 of the total mile, which means that Cesar only needed to run half of the total mile in order to qualify. So how do these 2 problems look if we use math to solve them? First, I want to go back to my original problem that used the half cups of liquid. In order to multiply a whole number times a fraction, I'm going to change the whole number to a fraction by writing it over 1. Then I can see, when I multiply, I have a pattern of the numerator times the numerator gives me the numerator in the answer, and the denominator times the denominator gives me the denominator in the answer. So multiplying 3 times 1/2, I would say 3 times 1 is 3 for the numerator, and then the denominator would be 1 times 2, which is 2. I can do the same thing if I had the roles reversed, where the fraction was first and the whole number was second. I will put the whole number over 1 first, and then I would multiply the numerator times the numerator. That gives me 3, and the denominator times the denominator gives me 2. Now we know from the picture that 3 halves is the same as 1½. That means the answer to both of these can change the improper fraction to the mixed number 1½. Now let's look at the problem with Cesar running around the track. He only needed to run 2/3 of the 3/4 of a mile that he ran in order to qualify. So if I write that in math, I have 2/3 of 3/4, and the of means multiply. So in math we would write that 2/3 times 3/4. Again, following the pattern from the first example, I would multiply my numerators together. So I have 2 times 3, which is 6, and then I have 3 times 4, which are my denominators, and that multiplied together gives me 12. Now we've already talked about being able to put our fractions in lowest terms. So my next step is to look to see if I can reduce this fraction. I know that 6 is a factor of 6 and 6 is a factor of 12. So I'm going to divide 6 by 6, and I'm going to divide 12 by 6. I'm able to reduce using this method because I am doing exactly the same thing to the numerator and the denominator. I'm dividing both by 6. That ends up giving me 1 over 2, which is 1/2. And when we look back at our original picture, we saw that he only needed to run 1/4 plus 1/4, or 2/4, which is 1/2 of the whole mile in 6 minutes in order to qualify for the race. For your assignment, when you come to class, I would like for you to have these two problems worked out mathematically on paper. 4 times 1/2 and 2/4 times 4/5. However, as an added challenge, which I know you are up to the challenge, I would like for you also to come up with a picture to represent each problem, just like the pictures that I showed you for these examples. See you in class.